given the 2 points. Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So today we're going to be looking at paper 2. I hope paper 1 is gone, so we're done with paper 1. So we are now concentrating on paper 2. We are talking paper 2 today. Now, remember in paper 2, you are going to have 4 topics. So it will be your analytical geometry, which is plus minus 25 marks. So at least today when we're practicing, we must target at least 15 marks. Those are the minimum marks that we must get. That's our target. I'm not saying after 15 marks and then you stop. So 15 marks. So now in trigonometry, it's 50 marks. So here at least if you can target plus minus 25 marks. So that's our target. Now we have Euclidean geometry there. If I can just target plus minus 10, that's my minimum mark that I must target. Okay. In circles, angles, and angular movement, this is a measurement. The measurement is also there. So here, at least if we can target plus minus 20 marks. Right, because there it's formula and substitution. So we can target that. So in total here, we target 40, 50, 60, 70 marks. So if I can target plus minus 70 marks in paper 2 as my minimum mark. So when I go into the exam room tomorrow, I know I need to start with the 70 marks. So I must go to analytical geometry and try to get 15 marks. Let's go to trigonometric, try to get 25 marks, and so on. So today we're going to be looking at all these topics and see which marks can you target. Which are the questions that we know? Every question paper will always have those questions, and we can get up to 70, which is our minimum. 1.5 hours. In the first 1.5 hours, go to that paper and try to get up to 70 marks in the whole paper. Then from there, you can then move. Then you can go back to those questions that you are not sure of. Then try them. Don't leave spaces there. Try those questions. Then you'll be getting to 80, to 90, to 100. And definitely you can be above 100 on this paper. Let's go to the next slide. In analytical geometry, these are the exam guidelines. I hope and trust your teachers have given you the exam guidelines, because those exam guidelines are tools that you can use in practicing your maths, your technical maths. So you understand that now I want to practice this technical maths paper 2. What should I do? I must be able to do the distance. I must be able to do the gradient. I must be able to do the midpoint. I must be able to do the equation of the line given the 2 points. Must be able to be given to determine the equation of the line through 1 point and parallel and perpendicular lines. So these are the guidelines, and I hope and trust you have all those. Inclination, equation of the circle, the equation of the tangent. These are questions that are going to be there. So when you take that paper, when you're practicing it today, try and see if all those things that are there in your exam guideline are indicated there. How to plot the graph of an ellipse. Okay. In trigonometry, you must know your trigonometric basic ratios. You must know your reciprocals. You must also know what special angles are. You must also know how to solve trig equations. Okay. You must know how to apply the sine, the cosine rule, and the area rule, apply the trigonometric identities and reduction formulae, solve 2D and 3D problems. In circles, angles, and angular movement, we have to take to know how to define a radian. We need to convert degrees to radians. We need central angles and arcs. We need to calculate the area of a sector. Okay. Again, we need to be able to calculate the height of the segment. We need to calculate the area of the segment also. We need to be able to calculate the angular velocity, the circumferential velocity. The formula sheet is there. Please make use of the formula sheet. Right, in mensuration, you need to know how to convert the units. Very important. Radians to degrees and degrees to radians and all that. You must be able to solve problems that include the volume and the surface area. The formula will be given, and we need to just apply those formula. We need to be able to calculate the area of the irregular figure using the mid-ordinate rule. We'll do one question on that one. Okay, right. Some exam tips for paper 2. Remember, paper 2 needs a lot of time. So time is of an essence, because you've got to work in your geometry, and on all those riders you must think which rider to use, especially in geometry. So most of the time we don't finish the paper because you spend too much time on easier sections. Those easier sections, try to do them quicker, so that then you have time to do your Euclidean geometry, which takes a lot of time. You'll answer the whole paper in an answer book. That's a nice one. See, if there are 3 lines, it means that you have to use the 3 lines or 2 or less. You can have 3 lines and then you have a sum that takes 7 lines. So if it's 3 lines, please make sure that you are restricted to those 3 lines. So finish your analytical geometry section quickly, because that's an easier section, because all the formulae are there and you will be able to substitute in there, so that you have extra time for your trig and your Euclidean geometry. Spend at least 1.2 minutes per mark. So in other words, each and every mark is 1.2 minutes. So some of the marks you'll finish them much quicker. If they say write down the coordinate of this point, and you can see that point is easier to do, and it's 1 mark, 1.2. Maybe you finish it in 30 seconds, and then the rest of the time you'll use it in your geometry, Euclidean geometry. Check your information sheet. Very important. Always check your information sheet. It's there at the back of your question paper. Check it time and time again, so that you don't write incorrect formula. Work on the diagrams in the answer sheet. You see, sometimes don't use your question papers diagrams there and work out something there, and then you go to your answer sheet, you write down the answer, and the teacher will not know what you have done, because the question paper you take it along. See, so please make sure that you on the answer sheet there will be a sketch. Work on that sketch. Okay, color it if you have to do, when you're doing your Euclidean geometry, color it, or analytical geometry, play around with that, and then from there you can then write down on the spaces provided, you write down your solutions. And sometimes we do mark the sketch. So if it's in your question paper, we'll not be able to see what we have done. So please make sure that you write all the lengths and angles you can find onto the diagrams. So that is a very, very important statement. All right, before we go to the exam type questions, can you just take a minute break?
Do you know that you are different? Do you know that your fingerprint is different? It's different from your peers, from the people that you are studying with. So do not compare yourself with your peers. Do not compare your results with what they're getting, because you are different. You have your own talents and skills, and also you have your own gifts. Embrace what you can do. Always put in the work to make sure that your results become better than what they were yesterday. But do not compare yourself, because when you compare yourself, you do not know what another person has, and they do not have what you have. So believe in yourself. You are different, and keep on putting the work.
Okay, now it's time for us to work on exam type questions. So all these questions, I've taken them from the exam papers. So let's look at how we're going to collect the marks. So remember we said in analytical geometry, we can then collect a plus minus 15 marks. And let's see. So remember, we must start by passing. Let's say I have this question, which is calculate the length of BC. So in the sketch there, we've got the length of BC. That's BC. Do I have coordinates on B and C? Yes, I do. So the question is 3 marks. Now, you must have read through the whole information there and check if that information that is there, it's on the sketch. So now, the A, it's indicated, it's fine. The B, it's indicated, it's okay. The C, it's indicated, it's fine on the sketch. D, it's indicated, also it's fine. BC parallel to D, it's also indicated there, it's fine. So I'm fine with that sketch. Okay. Now, out of 3 marks, for me to pass this, only this part here, I need one mark. Okay, so that's how I pass. So for me to pass this question here, the length of BC, I need only 1 mark. So now, if I get 1 out of 3, it means I already have 33%. So I've already passed if I got 1. So for me to get 1, it means I must write down the correct formula. So I go to my formula sheet, I copy the formula correctly. BC will be equals to the square root of x at B minus x at C squared plus y at B minus y at C all squared. Then from there, I substitute correctly. My formula is correct. I substitute correctly. Then I'm going to go on my substitution. X at B, it's 0. X at C, it's minus 8. It's 8 with a minus there. Y at B, it's minus 6. Y at C, it's going to be 0 squared. Then I'll have a 64. From here, I can go directly to my answer because I'll have my calculator with me. So I just put it as it is in my calculator. And now I'm trying to be smart here. I get square root of 100, which is going to be 10. So from here, directly you go there to your final answer. So you can see that it's only 1 mark there, 1 mark there, 1 mark there. So if I write the formula only, I already passed that part, that question. I've got, if I write a formula only, I've got 1 out of 3. If I write substitution correctly, I've got 2 out of 3. If I write this one, I've got 3 out of 3. Okay, so can you see how you can pass? So already here, I'm at 33%. Here, I'm at 67%. Here, I'm at 100%. So you see, so that's how you pass. You start passing with a sub question. So you take the sub question, you try to get 30%. First, you try to get 30% on that question, on that sub question. Then you move on to the next one. Okay. Right. Now check this one. 1.2. It's 2 marks. If I get 1 out of 2, I get 50%. So that part I've passed. Can you see how you can pass? Then you check here. What does the question want? Midpoint. You go to your formula sheet. You look for the formula for the midpoint. Then you do it correctly. So here, what is the midpoint? The midpoint of AB. So the midpoint of AB, which is E in this case. So I know the midpoint, the formula. Please do not write the formula without checking it in the formula sheet. That's very important. So my E here is going to be, I hope and trust everybody has already done it. You can be able to see that question there. So therefore it's minus 4 plus 0 all over 2. And the other one will be 4 minus 6 over 2. Then you write down your coordinates of E. And you can just check on your sketch and write the answers because you don't have a mark for that, right? So you only have mark for the coordinates. So here I can see my coordinates is minus 2 and minus 1. I go and check on my sketch. Can this be minus 2? Yes. Can this be minus 1? Yes. I know I'm fine with that question. So I'm done with that question. So I've got 1 mark there and 1 mark there. So you have 2 marks. Okay, right. So with this one, you know it's 1 out of that, but sometimes you make a mistake, maybe in terms of that, but make sure, use a calculator to do that. Okay. The next one, it's 1.3, which says determine the gradient. Remember, on the exam guideline, these things are there on the exam guideline. Did you practice the gradient? Do you understand what the formula needs? Do you understand how to do that formula? Great. Now let's see. Determine the gradient of BC. So the formula for the gradient of BC will be equals to. So BC. So the gradient, remember, it is the change in y over the change in x. So the change in y will be a negative. So I'm talking BC here. So the gradient of BC. So it will be minus 6 minus 0 all over 0 minus 8. So I'm going to get minus 6 all over negative 8. So the answer there will be 3 over 4. So that is my gradient. So the gradient there. So for you to write down, to substitute correctly into the correct formula, it's 1 mark. To get that, it's 1 mark. So it's 2 marks. So if I can just substitute correctly and maybe mess up with my calculator there, and I don't get, maybe I get a negative, I still have my 1 mark for substitution, and I've got 50% on that question. So can you see, try all these questions and you'll definitely get the marks. You can see the strategy now of getting up to 70 marks. Right. 1.4 says now we need to find the equation of the line. Can you see? The exam guideline has said you must get the equation of the line between the 2 points. So these are questions that are always there. The equation of the line through point D and E. But what do I know there? That line is parallel to that. And what do I know about parallel lines? Come on, guys. Parallel lines, same gradient. So now it means that I already have the gradient of BC. I got it in the other one, in 1.3. So meaning that what is the gradient of ED? Because they've got the same, I mean, they are parallel, so they've got the same gradient. So the gradient of DE or ED will still be 3 over 4. You see? So now here, if I come and say the gradient of BC equals to the gradient of DE, and that is 3 over 4, I already have 1 mark. And I've got 1 out of 4, so I'm at 25%. So what do I need? I need another mark. Where am I going to get the other mark? Then remember my formula. Y minus, you go to your formula sheet, you check this formula. You write it as it is. You see? So now, I'm having a point here. So I've got this point here that I got, which was minus 2 and minus 1. But I'm not sure about this point. Don't use it. Use the one that has been given to you, because it's on that line of DE. So I'm going to use point D, which is 2 and 2. And I hate working with negative numbers. And I need positive numbers. Fine. So here I've got negative numbers. And then integers sometimes, you know, they're tricky. So I want to work with the positive values. If I've got a chance to do that, let me do it. So I'm going to have y minus 2 equals to the gradient, which is 3 over 4, into x minus 2. Okay, that's nice. So now I'll have y, it's equals to 3 over 4 times x is 3 over 4x. 3 over 4 times negative 2, it's negative 3 over 2. Then remember the minus 2 that I took from that, I must add it this side. So I've got y, it's equals to, right? So now I need to add the 2 minus 3 over 2 plus 2, I'll have plus a half. Okay, then I'm done. That's the equation of the line passing through the point D and E. Okay, so you see you already have 1 mark for your gradient there. You've got 1 mark for substituting correctly, and then you have 1 mark for simplification there, and then you've got 1 mark for the final answer. 4 marks, 4 marks. So the 2 marks I can get from this. So my 2 marks will come from writing the correct gradient and substituting correctly into the correct formula. And then from there, sometimes I messed up somewhere there, and then from there my answer becomes wrong. Okay, so right. 1.5, the size of that. So that size, it's nothing else but inclination. You have seen that word inclination. All right. You have seen that word. So we need the angle. What do you know about the angle? The angle is going to be the tangent of that angle. Okay. So the tangent is equal to the gradient. The gradient of what? Of this line here. You see? Therefore, I can say the gradient of AC. So first, what should I do? I must get the gradient of AC. So how am I going to get the gradient of AC? I'm going to say, okay, for AC, it's going to be 0 minus 4 all over 8 minus into minus 4. Okay, then I'm going to get minus 4 all over 12. Okay, so the gradient there, it will be negative 1 over 3. So the tangent of alpha is negative. But I'm not done, because they wanted the size of that angle, which must be in degrees. Okay, so then I can use my calculator and say shift tan 1 over 3, and that angle that I'm going to get there will be, because remember, this is the small angle that we're talking about here. You see, there's the small angle that we're talking about. Okay, so now if I say tan alpha and then I don't use the negative, if I use the negative, it means that I must add the 180 degrees. Okay, but if I don't use that, then I can just because I'm going to get a negative angle if I use the negative there. So in this case, I'm going to now get a positive angle if I don't use the negative. So if I use that, then I get 18.4 degrees. How do I know I'm correct? Because that angle is far less than far less than 90 degrees. You see, far less than 90, which means that then I'm correct. Can you see how you can see that this answer makes sense? If I get 162 degrees, then there's something wrong. Okay, so that's how you see that you have an angle which is much closer to what you need. Okay, now that is where you have a triangle. When you're given a triangle or you're given a quadrilateral and all that, or kite and all that in that figure, or given the lines, that's how you do that question. You'll always get questions that talks to gradient, midpoint, inclination, equation of the straight line, all those are the type of questions. So in that question, you will have seen that at least in that question, it was 3, 10, 12 marks. Remember, we need 15 marks. So that question you can do. Then you only need 3 marks now to pass that part of analytical geometry. But let's move on. Now here you are given that O is the center of the circle, B is given as 3 and 4, nice. A and E are 2 points on the circle, A and E are 2 points on the circle. AOB is a straight line passing through the center, we can see that. CD is a tangent to the circle at point. So that point, what is a tangent? That point touches that point here. I can work from the sketch first. How do I work from the sketch? That point here, the tangent, and this line is a diameter because it passes through the center. It's always going to be perpendicular to that. If the lines are perpendicular, what do I know? The gradient of line 1 times the gradient of line 2 will give me -1. You see, I'm working from the sketch without looking at the questions. What else do I know about that? If that point is 3 and 4, that point there is going to be minus 3 and minus 4. Okay, flip that around. Remember, this is in the third quadrant. The third quadrant, the x is negative, the y is negative. So I flip that around. So already I've got that. So what else do I need? Nothing. Can I go to my questions now? The question says, write down the coordinates of A. I've already done that. See? Because I've worked on my sketch. I've written things that I know from the sketch. So I've already done that. It's minus 3 and minus 4. Great. So I just come here and say, my dear say, this is what you need. And from there, your teacher will just come here and give you a mark like that. And he says, well done. Because you have done very well on that question. You will have your 2 marks, 100% on that question. No problem. And you can see the question says write down. There's nothing to calculate. I'm just writing down. I go to my diagram, check my diagram, just write down the value of A. The coordinates of A. And these are called coordinates. There must be an x value and a y value. No equal sign in between here, please. Determine the equation of the circle. Circle. Go to your formula sheet. There's a formula, x squared plus y squared equals to r squared. But I can see that this is a coordinate 3 and 4. An x here and a y. Coordinate are written as x and y. Then I just go there and substitute correctly. Out of 3, I need 1 mark. So already I've got a mark there. So now, what do? 3 squared plus, put brackets, 4 squared equals to r squared. I don't know what r is. Then I'll say 9 plus 16 will be 25. My r squared is 25. So already I've got a substitution into correct formula. And I've got my value of r squared. What do I need now to get 100% on that question? I need to write down the equation. X squared plus y squared equals to 25. Because they said you must write down the equation of the circle. The r squared, we get it by using by substituting the 3 and the 4. Even if I substitute this point here, I still get the same answer. Okay, so there I get 100% on that question. Already from the 12 plus 2 plus 3, I already have my marks. I don't say you must stop writing. You must continue. But if you see that there's a question that you don't understand, because some of the questions there you find that they're a bit tricky, you must do them at the end when you already got your 70 marks. We are targeting 70 marks tomorrow on Monday. The next one says same question. Now it says write down the length of OE from O to E. It's a radius. I already know what the radius squared is. That OE cannot be 25 because 25 is radius squared. What is the radius? The line from the center of the circle to the point to the circle, to the circumference of the circle. So meaning that and they need the length. They don't need the coordinates. Please, you must understand this terminology. OE is the length. Even if it was on the left-hand side there, it will still be the length is positive. So therefore, it will be r squared, the square root of 25, which is going to be 5. So the length of that is 5 units. Okay. Do you remember what we did there? We said this thing there is 90 degrees. Gradient of line 1 times gradient of line 2, it's equals to -1. Now here they say, give a reason why AB is perpendicular to CD. AB perpendicular to CD. Your geometry knowledge now. Remember, the theorem that says the line, the diameter, a diameter and the tangent. So the diameter is perpendicular to the tangent. So it is the theorem and we need a reason. It is going to be tan perpendicular to diameter. Must know this theorems. Can you see now they're bringing in the geometry because we've got a circle, we have a tangent. Then they bring in the geometry. So the Euclidean geometry, you must know that. Okay. Determine the gradient of OB. So how do I get the gradient of OB? O to B. What is O here? It's 0, 0. Ah, I've got another point there, B there. Ah, but if I've got a 0, 0, look at the trick. Simple trick. If you've got a 0, 0 and a point here, because your circles will be at 0, 0, and you have got a point here, you just look at this point. It's 2 marks. Nothing much. Look at that point and say the gradient of OB it's equals to. Take the value of y, put it on top. Take the value of x, put it at the bottom. Done. Because it's 0, 0 here. So which means it's 0. It's 4 minus 0, which is 4. 3 minus 0, which is 3. So I'm done. Okay. So, but do it when we have a 0, 0, origin and a point going to the point. So the gradient of the OB there will be 4 out of 3. Okay. Then the next question, I'm still writing there. 90 degrees gives us -1. Now they say, complete the following. Look, these are free marks. Free marks. Complete the following. The gradient of OB times the gradient of CD. Do you have the answer? Yes, I can see. I can see that class right there with their teacher there shouting, yes, we know, it's -1. Congratulations. Okay, keep watching. Now, remember we are targeting some marks here. Determine the equation of the tangent of CD. Oh, tangent. What is a tangent? Nothing else. Straight line. Okay. So the tangent is a straight line. All right. So then need the equation of the line CD. But what do I know about the gradient of that line? Oh, I already know it. The gradient of OB. It's -1. It's 4/3. So meaning that what will be the gradient of the tangent? You still remember? You turn it and change the sign. The sign there is positive. I start by writing a negative, swap this around, and then from there I'll have -3/4. There's the gradient of the tangent. Because when I multiply this and that, I get -1. Now, the equation of the tangent, this line CD has got a point here. So I'm going to use B, 3, and 4. Nice, because I don't like negative numbers and fractions and all that. So now, then I say y minus y1 equals to m into x minus x1. Why am I using this formula? Because I said the tangent is a straight line in this case. So now, y minus y1 is 4, m is -3/4, the x1 is 3, so I got -3/4x plus 9/4 plus 4. Remember, I've taken that for that side. Now, I can just add this. I'm going to get -3/4x plus 25/4. Don't be like me. Use a calculator, my boys and girls. Use a calculator. If you don't know what is 3 plus 2, just go to your calculator. It will give you the correct answer. Okay, right. So you can see that question, it's so easy. It's so easy, but we need to understand what to do. Sometimes you can be given the equation of that line and they say get the point of contact, you see? Okay, then you'll have your gradient. Maybe they give you 1 point here. You'll have your gradient and you substitute the x value or the y value given, and then you get your point, your other point of contact. Okay, the last one says determine the coordinates of C and D. Point C and point D. What do you know about those points? This is the y-intercept. This is the x-intercept. You see how they asked it? Okay, because in some question paper, they'll ask you direct to say, Here's the equation, write down the x-intercept, write down the y-intercept. But with this one, they say determine the coordinates of D, which means that at C, the x value will be 0. Then I have an equation which I got, which was y it's equals to minus 3 over 4 plus 25 over 4. Because that's line CD has that equation. So if my x is 0, so there's x here. My x is 0, my y will be 25 over 4. Okay. At D, my y is 0. Then I need a value of x. So which means this one I must work out. So I'll have a 0 equals to negative 3 over 4x plus 25 over 4. Then I'll have 3 over x equals to 25 over 4. I need the values of x. And now x in this case will be equals to, I have to quickly work the run out. So I'll have 25 over 4 multiplied by 4 over 3, because then I'm multiplying this side by 4 over 3 also cancels out. Then I'll have the 4 and the 4 cancel out, and then my answer will be 25 over 3. Okay, so my value of that will be 25 over 3, because I've cancelled that 4 out, and then that will be around 8 point something. Okay, so I'll have 8 point something there. I know this is 5, 6, 7, 8 point something can be there. Can you see how I can see whether I'm right or wrong? So my point is there. This one we said it's going to be 25 over 4, so it's just above that. Okay, so here it's going to be 25 all over 3. Okay. Easy questions. I mean, I've not done anything that is very challenging, and I've just taken out those challenging questions and now try to do collectible marks where we can collect marks and we play around with them. And each and every question paper has got this type of questions. And I've not taken anything that is difficult. I'm not going to do it even today. Okay, so I'm just working on quite easy and straightforward stuff. Okay, all right. I'm working on level 1 and level 2 questions that can give us up to 70 marks, 70%. So that's it. And the rest of the stuff, then you can go and try. You know, you've seen it somewhere, you try it again. Let's look at this question that comes every year, 3 marks. I don't understand why you can get 0 in paper 2. There's no way I can get 0 in paper 2. Okay, so this is the simplest question, and you'll get it in each and every paper. They'll give you that, and they say, draw the following ellipse, which is that. See. Now, what do you do here to draw that? So you take the x squared, you say equals to 3, then you say x will be equals to plus minus the square root of 3. You go to your sketch, this is your y, this is your x, then you locate square root of 3, which is 1,7. So it's 1 there, 1,7 will be closer to that, I just put a point. There's a plus 1 and there's a minus 1, so it's 1 there, it's 2 there, so it will be somewhere there, so I just put a point there. Okay, right, so from there, I go to the y and say y squared equals to 9, y equals to plus minus the square root of 9, which in this case I know is plus minus 3. So I go to my y, I will count 1, 2, 3, I put a point there, say 1, 2, 3, I put a point there, and from there I take my pencil and I just trace these points like this, trace them again like this. Don't use a ruler, please. And then from there you have your beautiful ellipse there. Then from there you write 3, you write square root of 3, you write negative square root of 3, you write 3 there, and negative 3 there, and you're done. It's your 3 marks. 1 mark for that, 1 mark for the x, and 1 mark for the shape. This question is there on Monday. It will be there. Even if they ask it somehow, but it has to be there on Monday. Ellipse, how to draw the ellipse will be there. Okay, I put my head on the block on this one. This question, this type of question. I'm not saying with the numbers, please. I'm not saying go and memorize those 3 and the 9. They might change the numbers, but just know the procedure of getting your x-intercept and your y-intercept. Then you go to your sketch, draw it. It's 3. You already have 3 in your pocket. 3 marks out of 150. All right, let's go. Now, we're done with the analytical geometry. Then we look at the trigonometry. We're not going to waste a lot of time in trigonometry because we've done trigonometry last week. We have looked at the trick, a lot of trick there. So we're not going to waste time. Now let's look at trigonometry. In trigonometry, what are you going to have there? You have the length of you're given in the diagram. T is given as 4 and 3. Great, it is indicated in the sketch. Origin is 0, 0. That's origin. The reflex angle that is formed by OP, okay, with a positive, this is OT. Sorry. Right. OT with a positive x-axis, it's beta. So there's the angle that I'm talking about. Determine without using a calculator. Oh no, Will, you love your calculators. And when you see that statement, you're thinking, why should I put my calculator away? For the value, determine the value of each of the following. OT. Now, when we say don't use a calculator, we say don't use a calculator because then we can see that you have used the calculator if you have got decimals. You've got decimals, then we know, this guy, where do you get the decimals without using a calculator? We have used the calculator somehow. The length of OT, what should I do? I need to draw this and draw a line that is going to be perpendicular to the x-axis. What type of a triangle do I have now? A right angle triangle. What do I know about this value there? That will be on the x-axis, so it will be the x. This value there is parallel to the y-axis, so it should be the y. Then I have that. And already you have been doing this in class from grade 10, from grade 9. Theorem of Pythagoras. You have been doing this grade 9, grade 10, grade 11. You have been doing this. And you have been using the 3 and the 4. And obviously, the next one will be 5. But don't use it with any other ones. If I given 7 and 8, don't say the other one is 9. Because that one is a special one. It's called the Pythagorean triplets. Okay, so you have learned about that. So we've got OT, so I can say OT squared equals to the 4 squared plus 3 squared, which gives me 25. Therefore, OT will be equals to the square root of 25 plus minus. Remember, this is the hypotenuse, so it will always be positive. Okay, in this case, okay? Right, so the OT there will be 5 because it's the radius there. If we draw a unit circle around that, it becomes a radius. Right. Now I have that line there, it's 5, no problem. The angle is there. Now they need the cos of beta. Remember, now I need cos beta. Now, beta is there. What is cos? Oh, you're so cato. You always sing it, but sometimes you don't do the right things. Okay, you always sing it. Cos is adjacent over hypotenuse. Adjacent next to. So it will be 4 over 5. That is multiplied by 5 minus. Oh, this looks easy. The tangent of the beta tangent, it's opposite over adjacent. So it's 3 over 4. From here, please, my boys and girls, use a calculator if you don't want to mess up. But that's easy. 5 cancels out 5, left with 4. 4 cancels out 4, you left with 3. 4 minus 3 is 1. These questions are Pythagoras type questions. Mostly it's the first question in trigonometry or the second question. But look out for this type of question. Okay, sometimes they'll give you a sketch like this. I mean, a line like that. You need to connect this. Sometimes they will give you questions like a 5 tan of beta equals to 2, and they say beta is between 180 degrees and 0 degrees. Then you must just know where to work out. In which quadrant must you work out? Okay. So these are type of questions that they can get, but go and practice them. One of them will be there in an exam on Monday. 4.2, easy 3 marks. Calculator. You see here, they never said without using a calculator. So calculator, don't have a problem. They said calculate the values of x. If I can't get 3, I must at least get 2 out of 3. How do I get that? The cos of x, I'm going to say x is equals to, go to my calculator. Take out your calculators now. Press shift, cos. I know that I see that guy at the end, at the back of the seat is not pressing. X equals to, you say shift cos 0,5, and then you get the angle. The angle that you're going to get, all of us there, it will be 60 degrees. And now it's called a reference angle. Already you have got 1 mark. Great. Okay. The next mark will be 4. I know that this cos there, it's positive. Where is the cos positive according to our cast? It is in the first quadrant and the fourth. Therefore, my solution will be x is equals to 60 degrees. In the first quadrant, it's 60. In the fourth quadrant, is 360 degrees minus the 60, which is the reference angle. And that will be 300 degrees or 60 degrees. So your mark will be for writing 360 minus. The next mark will be for knowing that there is 300. Okay. Easy, straightforward marks that you must get. So sometimes you'll find that here they give you a reciprocal. They put sec. And on your calculator, you go and search. For 3 minutes, you're looking for sec on your calculator and then you cannot get it. Oh, you forgot. Sec is a reciprocal of cos. So you must press 1 over cos of that angle that is given. Okay. Right. This question, 6 marks. This you must get. All of us, we must get this question. No one must make a mistake of not practicing this type of question. Today I'm going to do it quicker, easy, straightforward. Have your calculators in front of you now, because I want us to use a calculator. We're cheating a bit for today only. Maybe in the exam you might try that, but let's try and do this using a calculator here. Now, listen to me. First of all, you must get 1, 2, 3, 4. Everybody must get 3 marks here out of 6. Everybody. Let's see how we get it. It's tan, right tan. All of us. Multiply by. It's cos, right cos. All of us. Squared. It's cos here, right cos. The right plus, and then right cos. All of us. Just put them in brackets. Please, all of us, let's put this in bracket. Right. And then there it's sine, you leave it as it is. Already, you are already on your 3 marks. Take out your calculators now. Let's check. In a calculator, press tan 360 degrees minus 1 equals to. Right. Everybody. I know you got the answer now. You said tan, let me do it also with you, tan 360 degrees minus 1, close bracket. I get negative 0, I don't want to read all these numbers, but I'm starting with a negative. So I'm getting negative. So what do? I put a theta, I put a negative. I'm only interested in the sign of that ratio. So the thetas will always be there, right? But now I need this. I need the sign here is negative. I'm done with it. So don't worry about those numbers. Now let's go to the next one. 180 degrees, we say cos of 180 degrees minus 1. Close bracket. What do you have? Negative. So we have a negative. So again, we have a negative here. But yay! Yes, this guy here is squared. If I square a negative, what do I get? A positive. So I'm fine with it. Next one. I go cos of 180 degrees minus 1. I just subtract a 1. Don't worry about any other number. I've got a negative. So meaning that here I'm going to get a negative. This one is fine. So now I've got 1 mark, 1 mark, 1 mark, 3 out of 6. I've got 50% on that question. Everybody must get this question. Okay. Next thing. The next mark will be for what? Look at this. I've got a tan. What do I know about tan? If you see tan in trigonometry, you don't know what to do with it. Change it. Sine theta over cos theta. Right, I've got a negative, remember. What do I have? Cos squared theta, I don't do anything with it. I just want to write this over 1. Okay. Negative times positive is negative. Cos theta. Multiply by what? By sine of theta. Oh, I forgot. Equal signs. My work must be neat, so that my teacher, when he is marking, then he doesn't miss some stuff there. Okay. Now that will be equals to, what cancels out? Cos, 1 cos cancel with 1 cos. You see now here I've got another mark here. So I already have 4 out of 6, guys. 4 out of 6. And this question, it's always there in an exam. Right. So what am I left here with? So I've got a negative. So I've got a negative sine of theta times cos of theta. Then there I've got a negative cos of theta times sine of theta. Okay. Then from there, what do I have here? So negative, it's like having negative a times b minus a times b. So I've got 2 of the same, and they're subtracting. So if I've got minus 2 and minus 2, I'll get a minus 4. So if I've got minus 1 of them and minus 1 of them, I'll get minus 2 of them. I've got minus 1 of them, minus 1 of them. Can you see they're the same? Cos, sine, cos. So they're the same. The order of AB and BA does not matter when we multiply. So here I'm going to get minus 2 of them. So I'll have 2 of them. Done. That's where I stop. Okay. So meaning that here I'm going to get 4, 5 marks, 6 marks, and I'm done with the 6 marks. Even if here sometimes, I get stuck, but I already have 4 out of 6, which is a very good mark for that question. Okay. Getting right along. This question again, what do I see here? First of all, I see a chord. What do I know about a chord? It's a reciprocal of sine, of tangent. So tangent, it's sine theta over cos theta. Chord meaning it will be cos over sine. So I'm going to have 1 minus sine squared of x multiplied by cos squared of x divided by sine squared of x. Then divided by, what do I see here? Common factor. That 2 on the square, it's not a common factor. Please. So I have a 2. What do I see here? Sine squared x plus cos squared. Oh, I remember our teacher told us this will always be equals to 1. It's a famous one. That's the only famous one in technical mathematics. Then sine squared x, cancel sine squared x because they're multiplying here. Then I'm left with 1 minus cos squared x all over 2, of which what do I know about this one? Will be the sine squared of x. You see, and I've taken only easy questions that can help you get up to 70 minimum. Right. Okay. Right. Hope we're clear with it. Make sure that you understand what we're doing. Make sure this, and sometimes with this question, they'll give you the answer and say, prove that this is sine squared x all over 2. I know they like to trick us, then they can say, prove that this is half sine squared x. Oh, and then from there you say, oh no, this one and that one, will they be the same? Doesn't look like, but they are the same. So remember there's a 1 here, so it's 1 over 2 multiplied by sine squared x. These are some of the basics that we have done in grade 8 and 9. Okay, so now we're done with that question, and that's 5 marks. Yeah, 5 marks. This examiner was very, 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 very frugal in terms of marks. I mean, 5. Maybe 1 mark for that. Maybe 1 mark for taking out a common factor. 1 mark for writing that answer. 1 mark for that. Now the 5th mark, I will not know. Oh, okay. The 5th mark is for writing this one as 1. Oh, nice. Oh, okay. Okay, good. Right. I like this examiner. Okay. Right. Now, the next question, the next part that we're going to do now is the Euclidean geometry. You see, now I've taken out easy questions, only easy questions where we can get up to 70. Up to 70. That's all that we need. Up to 70. Right. From there up to 70, 1.5 hour, because today's lesson is 1.5 hour. So I said in 1.5 hour, I want to get up to 70 marks. If I can get up to 70 marks in 1.5 hour, then the other 1.5 hour, I'm trying to get up to 90, up to 100. But the first thing that you need to do is to pass the paper. So take the questions that will make you to pass. The other ones that are giving you problems, leave them out for the other half an hour. But for the first hour, let's do that. Right. Now here we have in Euclidean geometry, what you need to do is your theorems, grade 8, grade 9, grade 10, grade 11 theorems. Then you'll understand this. So I'm not saying go back and start from your grade 8 and grade 9 theorems and no. I'm saying learn those basic things like sum of angles in a triangle, exterior angle of a triangle equals to the opposite interior. You know those ones. You know parallel lines. What do you know about parallel lines? What do you know about triangles that are similar? What do you know about triangles that are congruent? You know, what type of a triangle is it when I have two sides equal in a triangle? And what happens with the angles, or what happens with the sides if angles are given? Then also in grade 11, you must learn the work that was in grade 11. You must learn all those theorems and their weighting. Ooh, there are about 9 theorems. You learn also their weighting, the way they've put them together. If you learn those words and you understand them, you have this mark. That mark, it's very important. The first one says a line drawn from the center of the circle to the midpoint of the chord. I love to draw pictures. There's a circle. There's a line from the center. It goes to the midpoint of the chord. Oh, okay. I've seen this before. I know this line goes to the midpoint. So if it is the midpoint, what does it do? It's perpendicular. So the weight that is needed there is perpendicular. Oh, okay. You see now how I can get the weights. I read the statement and try to draw a picture. Draw a picture. Here it says angles opposite equal sides in a triangle. Oh, let me draw a picture. Triangle. There's opposite sides, that there are sides that are equal. So if the sides that are equal, what happens to the angles? The angles here will be equal. Angles opposite equal sides. So it means angles opposite equal sides in a triangles are equal. Because these angles are going to be equal. The sides are opposite. They are equal. Can you see? I draw a picture, try to get it. And the third one says, opposite angles of a cyclic quad. Oh, what do I know? Cyclic quad. Oh, okay. Cyclic quad. A quad. I've got a cyclic quad. What is a cyclic quad? Quad with all 4 points on the circumference of the circle. And they say, oh, by the way, I've seen this before also. I've seen my teacher saying this angle plus this angle will give me 180 degrees. So the word that is needed there is, remember in grade 9 we have done these words, supplementary, meaning that they are equals to 180 degrees. They add up to 180 degrees. So that's supplementary. Okay, so if you draw a picture, you'll get it right. So draw a picture and then I get it right. Okay. This question also, you see, in Euclidean geometry, if they ask you this question to complete the weights, the next theorem will be based on that theorem that they ask you there. So you see there, they've asked us about the line from the center of the circle to the midpoint of the chord. What does it do? It's perpendicular to the chord. Can you see? Already I have that. Meaning that that line and that line is equal. If I know this line, I know that line. So what should I do? And it's 6 marks. They say I must calculate the length of WR. But if I know TR, then I already know TW. Then I can just add the 2. Or I just multiply this line by 2. What do I see here? A right angle triangle. What do I know about a right angle triangle? Pythagoras. Done. That question is done. It's done, guys. It is done. We are done with this question. Might not actually do it because I already see you doing it. And I know. Okay. Now, with this question here, I'm not going to do the whole question, but I'm just going to do part of it so that then we have. So I'm going to say, okay, TR squared, it's equals to PR squared is the hypotenuse. Subtract the other side. TP squared. Then TR squared, yeah, it's going to be 9.47 squared minus TP 8.43 squared. And TR without a square will then be equals to 4.31 without a square. So it's units. Done. You see, and that's the 6 marks. But now the TR, I know it's 4.31. What do I need? I need the whole of WR, which is 2 times 4.31. Then I get 8.62 units. That's WR. Oh, done. 6 marks. Oh, 6. Oh. So I need how many in Euclidean geometry? 10. I already have 7 or 8. So 6. I'm left with 4 marks. Oh, 4 marks. Okay, let me see. Where do I get the 4 marks? Oh, this one is 6 again. Oh. Let me not look at the question. Let me go directly to my sketch. I'm not going to do this. I'm going to my sketch, and then from there you are going to do this, because I've been talking, and you haven't done anything. I see some of you, they're just sitting there with no books, no calculator. Now it's time for you to can try this one and do it. See if you can do it. Right, let's see. In the diagram, O is the center of the circle, right? No. BAO, it's 40. Great. And then calculate the size of BCA. We need this angle here. We need that angle there. I'm going to give you 4 minutes or 3 minutes. Let me say 3 minutes, because that it's statement and reason, so 3 minutes will do for you. Okay, so let's take the 3 minutes and do this question quicker. Now I'm just going to give you answers at the end, because you will have done it, and then we'll check your answers. Your 3 minutes start now. Okay, let's see how many of you have tried to get to C, to BCA. Right. Now remember, this angle is given as 40, and this is a radius. Which other line is a radius? OB is also a radius. The radii are equal. Oh, can you see now? The theorem that we have talked about the previous slide was angles opposite equal sides. The sides are equal, the angles are going to be equal. Then at least now you say angle OAB is equals to angle OBA equals to 40 degrees. The reason is at the previous slide, angles opposite equal sides. Okay, so angles opposite equal sides. Right, so now I've got that one is 40. This is a triangle, in triangle AOB. So in triangle AOB, listen to this. We have a 40. We have a 40. This is a triangle. Can you see there? It's a triangle. The sum of angles in a triangle equals how much? 180 degrees. Meaning that angle AOB will be equals to 100 degrees. And that will be sum of angles in a triangle. You see, now I'm writing, I'm giving the reasons also. Okay. And the nice thing about Euclidean geometry in technical maths is that most of the time you find that you have a statement and a reason, and it's 2 marks. Statement, reason, 2 marks. 1 mark for the statement, 1 mark for the reason. Okay, especially with the reasons that are from grade 11, and also grade 12. So here, grade 11 work, you must get these marks. Now, I know now this, so when I'm doing this, you see I'm writing that in my sketch, because then it gives me a picture. I love pictures. It gives me a picture to say, okay, the triangle is done. Oh, now I can see I've got angle at center. It's twice angle at the circumference. Okay, it's a question paper. With you is a question paper. Turn the question paper around, and you'll see the way that you have been taught at school by your teacher. You will remember that diagram. So you remember that diagram whereby the teacher, I know most of the teachers, I know myself too, I teach it first by using that, to say angle at center is twice angle at the circumference. Okay, right. So now it has been turned upside down, and then, oh, you have never seen it before. Come on, guys. You've seen it, then it's a question paper, turn it around, and then you'll see, you'll remember it again. Now, we know that now angle BDA will now be 50 degrees. The reason will be angle at center equals to the angle twice the angle at the circumference. Right. Okay. Now I go to my diagram, I write this thing there, it's 50 degrees. What do I know about BCAD? Can you see that four-sided figure? Oh, okay. It's a cyclic quad. In a cyclic quad, what do I know about opposite angles of a cyclic quad? They are supplementary. Can you see that question here? It resonates to the question that we have done in the previous slides, where we were asked those three theorems and we needed to complete their weighting. So can you see the first one was the line from the center of the circle. We have done the question on that. The second one was angles opposite equal sides. It is there. The third one was opposite angles of a cyclic quad are supplementary. Therefore, angle BCA will be equals to 130 degrees. Then what is my reason for that? Is the opposite angles of a cyclic quad. The cyclic quad, you see. Learn those reasons. Those reasons are there in your examination guide. You see, I'm stressing the examination guidelines. They are there in your examination guidelines. If your teacher has not given it to you, please make sure that maybe by the end of today you send him a WhatsApp or her a WhatsApp and say, ma'am or sir, can you please send us an examination guidelines? We want to practice our technical maths this weekend, and we need it. We need that examination guideline because we want to practice with that document. All right, now. Then we are done. Then that's the 6 marks. You see how easy that 6 marks was? Then I go to my sketch and write it. Maybe there will be other questions. Maybe there will be other questions that need. Maybe this is 7.2.1. There's 7.2.2, which needs us to get the other angles. But in this case, I think we have done almost all the angles. So we are ready to go. Okay. All right. So you see your geometry, it's 40. We need 10. 10 out of 40. That's all we need. 10 out of 40. So that 10. Make sure that you go to that question paper and look for question 7, 8, 9. 7 and 8, or sometimes to question 9, and check if you can get up to 10 marks only. 10 marks only. That's all that we need in the first 1.5 hours. We need that 10 marks. Then the rest you can go back and say, oh, okay, I think I remember this one. Then let me go for it. Okay. Now, this topic also very easy topic. Why am I saying this? It is because the marks, the formula sheet are there, and those formulae, you must know them. The formula for this topic, they're in the middle of your formula sheet. You'll get them, and they are written. If it's an arc length, they'll say arc length. If there's a circumferential velocity, they'll write circumferential velocity on the formula. If it is area of the sector, they'll write area of the sector on the formula. So I don't understand why you don't do this question. Oh, because it is there in question 9, 10, 11. No, go there. Start there. You can start there in that question, and then because the formula are there. And this is a section where you can pick up easy marks. That's why I said 20 out of 35, because it's easy questions. Let's look at the first one. They say O is the center of the circle. AOB is given, that angle is there. The diameter is given as 10.85. So you know that there's a diameter. Convert this to radians. This is easy, 2 marks. Calculator. Put it on a calculator. So what do you say? 108.5 multiply by pi over 180. Know that this is the formula for changing this into. That's a simple 2 marks. You go to your calculator, you work it out, and I think the answer there is supposed to be 5.42. Sorry. So that will be 1.89 radians. That's all that you do. So these are easy marks. The length of the radius, 1 mark. I mean, already I've got 3. The diameter is given. What do I know about the diameter and the radius? The diameter, I mean the radius, is going to be half of a diameter. Then from there, I'll quickly know. So that is going to be 5.42. Okay, and that is given in centimeters. I must not forget to write down that. So I've got my radius. I've got my radians. There's a difference between those two. Radians is the measure of angles, and the R is the radius, which is the length. Okay, so we must learn the difference between the two. Okay, so now I already know that this is 5.42. That one is radians, so it's 1.89 radians. Okay. In the next question, they'll say calculate D. Now, D, it's not a diameter. The D is the length, is an arc length. So they just wanted to trick you a bit. D is not a diameter. Don't come here and write D equals to 10.84 because you said D stands for diameter. No. They said even D is the length of the arc. The length of the arc. You go straight to your formula sheet. You look there in the middle of the formula sheet. I'm even directing you where to go. You go to the middle of your formula sheet. You're going to get this formula. It will be written length, arc length. And it will start with S. It's equals to R multiplied by theta. The theta here is in radians. Do you still remember the first question? They said change to radians. So already you have answers. The radius you already got in the second part of the question. So you'll have 5.42, just like that. 5.42 multiplied by 1.89, just like that. Just like that. And then I get 10.26. And that is centimeters because it is the length, arc length. It's in centimeters. The 3 marks, 1 mark for the formula, 1 mark for substitution, 1 mark for the final answer. What is your problem? You have the formula in front of you. Okay, right. Calculated the area of the shaded sector. So can you see that part is shaded here? Okay. Right. So calculate the area of the shaded sector. So you go to the formula sheet, you look for the formula in the middle of the formula sheet. It will be written area of the sector. There are two formulae there. So there's a formula that says A equals to RS over 2 or area equals to R squared theta over 2. But here already I've got S and I know what is my R. Okay, so can you see I've got R, I've got S. Just substitute 5.42 all over 2 times 10.26. Then I get my formula. I've got my answer there. So my answer there becomes 27. I'm not interested in the answer anyway. I'm interested in how to get there. Okay. With this one, obviously, I'm going to substitute my R. It's 5.42 squared multiplied by. So your theta. Remember your theta is your angle in radians. Remember, when you're dealing with these sections, our angles are in radians. So we must always know how to change them back. So the R is in radians, so I'm going to write 1,89. I'm not going to write 108.5. So there, if I work that one out, I'll still get 27.8. Square centimeters, remember its area? Remember its area? It's square centimeters. Okay. Hope we all get this right. So remember, this is in centimeters, this is in centimeters, 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 centimeters squared. This one is already in centimeters, so squared, we get it. Okay. Right. Same questions, yeah? You'll get this type of questions. And the formula, as I said, they are there. and they're written. In this case, they say a wheel of diameter 570 millimeters. You see, and you must be very careful, because in your questions, they might say, give it to us in meters per second. Here it says 15 revolutions per second. You see, this one is already per second. So sometimes they'll say per minute and they want it per second. So this is very, 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 that's why we miss marks, because we don't convert and we don't read. And we read, you must read, and from there you must listen to what you're reading. Okay, pay attention to what you're reading, and from there read the question, and you can read the question twice so that you understand. The angular velocity, remember, it only deals with revolutions per second. So meaning that my formula, it will be there. It's not W, please. It is omega. So omega is going to be 2 pi n. So can you see? Or you only substitute your number of revolutions. So you'll have 2 pi multiplied by 15. Remember, the revolutions is already per second, which means that will be 30 pi revs per second. See? Right, because that's all that we need. So now, the angular velocity, it's done. 3 marks, 1 mark for the formula, which is there in the formula sheet. So even if I write the formula only, I'll get 1 out of 3, which is 33.3%. I've passed. Okay, yeah, 2 at least. But here, if I write down the formula, I've passed. So we don't want to see gaps. We don't want to see empty spaces on Monday. The circumferential velocity in meters per second. Circumferential velocity, remember, it's V equals to pi d times pi. The diameter, remember, they want it in meters per second, but the diameter is given in millimeters. Do you see where we mess up, ne? So we must check. If it was given in meters and they need it in meters per second, that's fine. Substitute it as it is. But how many meters do I have in 500 meters? So in this case, I'm going to have divided there. Then I'm going to have that. I'm dividing it by 1,000. Remember, I've got millimeters, centimeters, decimeters, and meters. So it's 1,000. So remember, this is in meters now. Then my revolutions is 15 revs per second. So that one is fine with me, because I've got per second here. So which means it's going to give us, answer there, it's going to give us 8.55 pi. Okay, and that is meters per second. I can still multiply this thing there by pi, 8.55 by pi, and I get the answer. But if I leave my answer like this, you'll get a mark. If I leave your answer like that, you'll get a mark. Okay, because then if you multiply it by pi, then the answer is not exact. You see, with this one, it's exact. 30 pi is an exact angular velocity. 8.55 pi is an exact angular velocity. Okay, right. Circumferential velocity. Okay, in the next 2 minutes, in the next 2 minutes to 3 minutes, I'm going to look at the last question there, which some of us also miss. They don't do this question, and I don't understand why. Because it comes every year. It is there every year. The formula is there. You've got two, for this, Wes, you have 2 formulae for this. You can pick and choose which one you want to use. Okay. Now it says an irregular shape has one straight side, length of 12 centimeters. So that's the one straight side length of that to that. And it's divided into 6 equal parts. And they give you 1, 2, 3, 4, 5, 6 equal parts. The ordinates dividing the parts are the given, it's 4, it's 4.5, it's y, it's 4.4, it's 3.7, 3.5, 3.6. So we've got 1, 2, 3, 4, 5, 6, 7 of them. So now it says calculate the value of A, which is the equal parts. You see, these parts are equal. See, these parts are equal. So, but we say the length, it's 12. Simple mark. Everybody must get this. So it means I'm going to say A will be equals to 12 divided by 6 parts, because I've got 6 parts. 1, 2, 3, 4, 5, 6 parts. So I'm going to say A divided by that, and then I'm going to get 2 units. See, so it's 2. My A is going to be 2. As simple as that. This 1 mark everybody must get. If this question comes, sometimes they give it to you. They say this is 2, this is 2, this is 2, this is 2, this is 2. Okay? So sometimes they give you the whole length. They want you to do that. Okay. Now, these are the formula that I was talking about. These are the 2 formula that I was talking about. They're there. And they tell you A is equal parts. You see, A is equal parts. Nth ordinate is the nth ordinate, and n is the number of ordinates. M1 it's 01 plus 02 divided by 2. N is the number of ordinates. So, really, they give you this formula. And they write, they give it, they even explain what that formula it's all about. And they explain each and every value there. Now, in this case, they say calculate the value of y if the area is given as that. So, meaning that my formula there, the area is given. So, I'm going to write 49.6 square centimeters. It's equals to, equal parts, it's 2. Remember, now I'm going to use the formula which has the first part, 01, plus the last one, divided by 2. And then I add the other ordinates. So, adding the other ordinates, I've got 4.5 plus y plus 4.4 plus 3.7 plus 3.5. Okay. And then from there, I can add all these values, this one, that one, this one, that one, and that one. And if I add that, I get 39.66 because I've already multiplied by 2. Then plus 2y. So in other words, I've added this, that, and that, and that, and multiply that by 2. I get that. And then from there, I then multiply the 2 by the y, I get 2y. And then the 49, it's still there. Then I'll say 2y equals to 49 minus, 49.66 minus 39.66. And I'll get 2y, it's equals to 9.94, of which my y will be 4.97 centimeters. So this is how I'm going to do that question. And that question must be done. If you see it the next week, Monday, please attempt it. Okay, use the formula that are there. Okay, I'm going to stop here for today, and I want to take this opportunity to wish you good luck in paper 2. Paper 1 is gone. Please leave that paper alone. We'll see it when we do revision for the final. But paper 2, this weekend, it's you make a festival of that paper tomorrow and on Sunday. Thank you so much and good luck.